Hello and welcome to video demonstration of the Building Energy Manager application developed for the Targeted Energy Management Systems Toolsets project. In this video, we will go over the basic graphical user interface, the basic functionality, anomaly detection and visualization, linguistic information presentation, and additional functionality implemented in the Manager application. Now we will look at the graphical user interface of the Manager application. This is the graphical user interface of the application. It is divided into two areas, a control pane and an interactive graphical interface. The control pane consists of controls for various functionalities. These include display control, time selection control, anomaly type selection control, anomaly selection control, anomaly model control, sensor selection control, and anomaly display control. The graphical interface contains different areas to display important building behavior information. First, it contains an information area that displays the building name, selected flow, and selected time. This is the building level view, which provides an overview of the building and enables users to select different flows. The floor plan of the selected flow is displayed in the flow view area. Building level and air handling unit level data is displayed in this area. A plot area is provided to plot selected sensor data. Finally, linguistic descriptions of selected building behavior is displayed in this area. This concludes the overview on the graphical user interface of the application. Now, we will look at the basic functionality of the Manager application. The building level view on the left-hand side shows the flows of the building. In this example, there are 11 flows. The color of each flow is a representation of the average zone temperature of that flow, where green is normal, blue is colder, and red is warmer. Using the building level view, you can select a flow to visualize detailed data. This is achieved by clicking on the desired flow. Flows with no data stream available are grayed out and cannot be selected. Once the desired flow is selected, the flow number of the selected flow is displayed here. The flow plan of the selected flow is displayed in this area. The flow plan is a representation of occupant temperature zones, and the zone labels are also displayed. Similar to flow color, the color of each zone represents the temperature of that zone. You can click on any zone to select it. The selected zone is indicated by a white border around the zone. Once a zone is selected, temperature of that zone is plotted in the plot area in blue. On the right hand side, various different sensors related to the HVAC system is displayed. Each sensor is identified by a three-letter abbreviation. For example, OAT is outside air temperature, CLT is cooler temperature, MAT is mixed air temperature, and so on. Similar to flow and zone colors, the accompanying colored box indicates the current value of the sensor, where red corresponds to high sensor values, green medium sensor values, and blue low sensor values. The actual value of the sensor reading is also displayed along with measurement units. If you click on this colored box, you can select the sensor. A differently colored border appears around the colored box, indicating the sensor is now selected. You can deselect by clicking on the colored box again. Once the sensor is selected, a plot of the sensor value is displayed in the plot area. For easy identification, this plot is displayed in a different color. And the color of the plot is the same color as the border around the colored box of the selected sensor. Therefore, you can plot multiple sensors in the same plot area and easily identify each. The time and date of the current data point is displayed here. To move one step forward or one time step backwards, you can use the time step control buttons located in the control pane. As you can see in this example, one time step is 45 minutes. The time translation control enables you to move forward and backward in time faster. This concludes the demonstration of the basic functionality of the Manager application. Now we will look at the anomaly detection visualization of the Manager application. If an abnormal building behavior is detected, it is emphasized using several visual cues. First, an anomaly indicator is shown at the building level view beside the floor where the anomaly has occurred. Once you go into the floor plan, the zone where the anomaly has occurred is emphasized by using a red border around the zone. In the floor display control, if you select Anomaly Display, the color of the zones and the color of the flows represent the anomaly level of each zone. Here, red means high level of anomaly and green means lower level of anomaly. To quickly move between anomalies in the selected flow, the Anomaly Selection dialog can be used. Here, clicking Next takes you to the next available anomaly for that flow, and clicking Previous takes you back to the previous anomaly for that flow. Anomaly type can also be selected from the control pane. Cluster-based anomalies are general anomalies detected by the data-driven fuzzy clustering algorithm. Expert rule-based anomalies are general anomalies and are identified using expert rule base. The combined view shows both cluster-based and expert-based anomalies. Comfort and efficiency anomalies are building performance metrics identified using linguistic expert knowledge databases. Each of these different types can be identified using the letter in the anomaly indicator. For example, cluster-based and expert rule-based general anomalies are indicated using letter A. Comfort-related anomalies are indicated using letter C. Efficiency-related anomalies are indicated using letter E. The sensor selection dialog enables you to focus on specific sensors. For example, if you want to identify anomalies that are caused by zone temperature only, you would have to deselect all the other sensors and select only the zone temperature. This will remove some anomalies that are occurred due to other sensors. The threshold value is used to control the number of anomalies that is displayed to the user. If the threshold is higher, then a smaller number of anomalies will be displayed. Similarly, if the threshold is lower, the number of displayed anomalies is higher. This concludes the anomaly detection visualization demonstration of the Manager application. Now we will look at the linguistic information presentation and analysis methods implemented in the Manager application. Once an anomaly is detected, the user can click on the zone where the anomaly occurred. This will display a linguistic description of the anomaly in the linguistic description area. First, the anomaly type, which in this case is cluster based, and the anomaly confidence, which in this case is high, is displayed. Second, the sensors that cause the anomaly is displayed. Here, along with the sensor name, the value of the sensor that caused the anomaly is displayed in linguistic terms. In this example, the sensor was zone temperature and the value of the zone temperature was low. Since more than one sensor may cause an anomaly, users are able to list up to 3 sensors that cause the abnormal building behavior. This is done using the control pane. Furthermore, the listed sensors are displayed in the order in which they caused the anomaly. For example, for the shown anomaly, zone temperature was the primary reason the behavior was identified as an anomaly. Hence, it is displayed first. The second reason for the anomaly was return air temperature. Therefore, it is displayed second. And finally, the third reason, which is the exhaust fan current, is displayed. Using the sensor selection and the plot tools, the user can plot each sensor and further analyze the cause of the anomaly. For example, here the zone temperature is already plotted. Using the sensor selection, the user can plot return air temperature. The exhaust fan current can also be plotted. These plots can be used to further analyze the anomaly. Similar to cluster-based anomalies, once an expert rule-based anomaly is selected, the linguistic description is displayed. However, in the case of expert rule-based anomalies, the rule that caused the anomaly is displayed. As before, the sensor selection and the plot tools can be used to further analyze the anomaly. This concludes the linguistic information presentation and analysis demonstration of the Manager application. Now we will look at some of the additional functionality that is implemented in the Manager application. Additional functionality for anomaly detection model updating and report generation is also included in the manager application. Once a cluster-based anomaly is detected, if the building manager or another expert decides that the detected anomaly is actually normal building behavior, the user can mark it as normal behavior. By doing this, the user is training the anomaly detection algorithm to identify the selected building behavior as normal. To do this, the user has to select the Decide Anomaly and click the Mark as Normal button. Now the anomaly is identified as a normal behavior. Once a new behavior is marked as normal, the updated anomaly detection model can be saved using the Save Model button. The Reload Rules button enables users to upload new expert rule-based rule sets to the anomaly detection model. Finally, the Generate Report button enables users to generate textual reports for a given time period. This report is saved in a text file. This is an example of a generated report using the Manager application. It contains detailed information about location, time, and a linguistic description of the detected anomaly. This concludes the demonstration of additional functionality of the Manager application.